All right, this is the post-mortem call on December 20th, 2018 for CVE 2018-1002105. So on the call are participants from sig-auth and sig-api-machinery and from the security group for Kubernetes. This document that we're going to be reviewing has already been constructed and reviewed by the people who participated in the incident, and so I'm going to be reviewing the document, answering questions. If you have questions, feel free to add them to the doc or call them out on the call, and we can discuss them. And then after this call, we'll be publishing this document as a PDF linked to from the website somewhere. All right, so I'm gonna just start reviewing this, and feel free to interrupt with questions, and we'll go from there. So just to summarize what the issue was, there was a vulnerability that allowed TCP connection reuse for connections that were proxied through the API server to backend servers. And the two escalation paths that were known were through the API server to aggregated APIs, and then through the API server to kubelets. In particular, calls through the API server to aggregated API servers could be exercised via discovery APIs that were by default permitted to anonymous users. The escalation path to the kubelet was via the pod exec attach import forward APIs, and those are not permitted to anonymous users by default. So that typically would be a low privilege to high privilege escalation. There's a link to the GitHub issue that really dives into a lot of the details about which particular versions were affected, which particular configurations. So if you're interested, feel free to follow that link and find out more, but hopefully most people are familiar with that by now. Jumping down to the timeline for the incident, the bug was first reported publicly against the Rancher component, actually. They made use of the API server, and some users noticed that when load balancers would speak to the API server, this TCP connection reuse vulnerability would actually manifest as a bug where a connection would get stuck open and the load balancer would reuse it and then get error responses that didn't make any sense. So it sat as a bug report for a few months while they were trying to figure out what was going on with it. The beginning of November, Rancher devs actually root caused it and found the bug and reported it privately to the Kubernetes product security team. Within a few hours, the report was acknowledged. By the next day, a proof of concept exploit was produced, and the next business day, a fix was opened for review. The following day, a second proof of concept exploit for the anonymous upgrade attack was produced. And so that lengthened the review process to make sure that all of the ways that this could be exploited were understood, and that we knew what the severity was before we moved forward. The following day, the review was completed, and CI tests in the private security repository were green with the fix, so end-to-end integration and unit tests were passing. At that point, the communications for the pre-disclosure were put together and reviewed, and were sent out to the Kubernetes distributors announced list on November 9th, with a release time frame of releasing cutting releases containing the fix on November 26th, and publicly disclosing the vulnerability on December 3rd. December 3rd happened to coincide with the release of 1.13 as well, which was fortunate, I guess. So the issue was resolved in versions of 1.10, 1.11, and 1.12 on November 26th, and was also included in the 1.13.0 release on December 3rd. Analysis of the root causes revealed that the proxy components, the particular component that had the vulnerability, had existed since Kubernetes 1.0, and originally was used for pod exec and port forward, and then later was used for additional proxy use cases, specifically the aggregation, when that was added in the 1.6, 1.7 timeframe. Those components, the test cases were primarily focused on making sure that the function that they were used for worked correctly. And so the tests were primarily positive tests, not testing error conditions or negative tests. Another cause was that proxying in the Kubernetes API server still uses HTTP1 upgrade-based connection tunneling rather than something like HTTP2 proxying. That means that when a request from an end user is proxied through to a kubelet, it drops down to a TCP connection, and there's no distinction made between the request that the API server made and subsequent requests from the user. And finally, the method used to transfer authentication information from the API server to backends is secured via a mutual TLS connection, and both high and low privilege API requests are proxied in the same way, which allowed a low privilege request like a discovery request via the discovery API, once that dropped down to a TCP connection, to be reused to make high privilege requests like mutating API requests. So those were the technical root causes. Most of the lessons learned were around the actual review and release process. And so I wanted to jump down to some of the action items that came out of the technical root causes before we go through some of the existing feedback. So some of the issues that have been opened, either to investigate changes or to lock down existing behavior. There is an old issue for switching away from speedy proxying and specifically to HTTP2, but it is also being used to look at switching from HTTP1 upgrade proxying to HTTP2 tunneling. Another item is to lock down the upgrade protocols that we allow to the ones that we expect, so specifically speedy and WebSockets. A lot of these are kind of done in parallel. If we switch to HTTP2, that would remove the need for locking down the upgrade protocols, but something like the HTTP2 switch is likely to take longer because of deprecation policies and maintaining API compatibility. And so we're looking for ways to reduce our surface area in the meantime. Straightforward things like adding tests of error conditions for proxy components. This was actually done as part of developing the fix for the CVE and was opened as a public PR after disclosure. There are a couple of issues opened to track improving how the aggregation of discovery APIs works. One, to sort of air gap discovery requests so that requests to the aggregator are not played to the backend servers, but rather the aggregator does discovery doc fetching and then serves those from cache. Another possible change would be to place limitations on which requests are even allowed to serve upgrade requests. So because the aggregator has knowledge about the structure of the API, it can potentially make decisions about which requests would even allow upgrade if they follow known API path patterns. There is a security audit that is currently in the proposal stage and will be performed early next year. And so one of the follow-up items from this was to identify specific components like this proxy component and specific scenarios like proxying through the API server to aggregated servers or the kubelet that we want scrutiny on during that security audit. And so I'm taking the action item to coordinate with the security audit work group to make sure that the list of components and the areas of the code that we want to be scrutinized are make it into that process. In addition to specifically testing error conditions, fuzz testing could possibly have helped catch some of these things. Like I mentioned, this was originally reported as a bug that was encountered in the wild, and so it was possible to trigger with accidental requests, and so fuzz testing that would have triggered an error condition in the backend could possibly have detected that it wasn't being handled correctly. In the interest of reducing the attack surface available to unauthenticated requests, there's an issue open to investigate narrowing which endpoints are allowed to anonymous users. Currently, unauthenticated requests are allowed to obtain health information, which is basically an up or down signal if the API server is healthy, version information, and discovery information. Health and version are likely to continue to be allowed because those are frequently used by load balancers that don't have the ability to authenticate. But those are much better understood APIs. They don't involve proxying to other servers. They don't have complex handlers. And so that issue, 72115, is open to track investigating removing discovery permissions from anonymous users by default. (72116) is open to track investigation of adding request binding information so that when the API server acting as an authenticating proxy forwards a request to the backend, it could add information into the request to indicate what particular URL it was intending to forward to. So that in addition to the channel secured request, the MTLS secured request, there would be something particular to the request in the headers that would let the backend verify that this particular request was intentionally forwarded. 72117 is open to investigate alternatives to proxying through the API server for things like pod exec. This has long been discussed, and there is interest in it. It is unclear whether the security posture would be improved just by splitting out the proxying to a different component, if that component was required to have the same level of authority to the backend. But if you are interested in that or have ideas around that, that is an issue to follow and comment on. All right, that is the end of the technical action items. The remaining ones are around communication and the release process itself. And so I'm going to jump back up to the lessons learned section. I do want to pause there, just if there are questions about any of those action items or other points that people wanted to raise on the technical side before we continued.
Hi. Are the exploit private or public?
I'm sorry? Can you repeat that?
Are the exploit private or public?
The exploit?
Yes. Are they public or private?
The proof of concept exploits have not been released. I've seen a couple that have been produced by third parties, but the product security team has not released our proof of concept exploits.
Okay, thanks.
Mm-hmm. All right. If you have other questions or would like to follow any of these issues or comment on them, please do so in the issues. That'd be great. All right, jumping back up to kind of the feedback on the actual review and release cycle. So things that went well, the private review and testing went smoothly. That's good. That hasn't always been the case. The timeline that was provided to distributors to test and release the fix within their distributions, feedback was that the timeline was reasonable. It was particularly tricky just given the time of year and that holiday freezes and Black Friday and things like that were in play. And so trying to navigate those in addition to getting the fix out as quickly as we could and making sure it made it into 113 as well. Those were kind of the things we were trying to balance. But the feedback was that the timeline ended up being fairly reasonable. Coordination between the security release team, or the product security team and the release managers went well. We used a sort of a single canonical release plan doc to coordinate that, make sure everyone understood what was happening on what day. That went well this time. And then finally, the embargo on the pre-disclosure during the 2 weeks when it was disclosed to distributors before the public releases were cut. Embargo was maintained, which is appreciated and gives us confidence that we can continue to make fixes and coordinate with the distributors and get information out into the public responsibly. All right, so some things that we got feedback on that could have gone better. Not all of this was publicly visible, but the initial announcement to distributors had a CVSS score that was high. It was still critical, but it didn't consider the ability to impact workloads availability via this vulnerability. And so we had a follow-up that increased that score to the one that is in the public issue now. We're still trying to figure out how to map some of the metrics for these vulnerabilities to the CVSS score, given that different configurations might be differently affected. The public releases were still cut publicly. So on the 26th, the fix that had been tested and reviewed and given to distributors was opened into the public repo. And then there was a time delay of several hours while that merged and CI ran and build artifacts were produced and RPM and Debian packages were built and pushed. We would still like to shorten the window from when a fix is publicly visible to when the release artifacts are available. This was a minor issue, but CI in the private repo continually atrophies, and because we aren't continuously cutting security releases, thank goodness, it means that when we do jump into the private repo to do this, there's usually CI fixes that need to be made. So that delayed us about a day. If you look at the timeline, the review completed on the 6th, and it took us until the 7th to get green CI. So that was trying to get that working again. While we were cutting the releases, the patch managers for the 3 releases are in drastically different time zones. And so there was some coordination difficulty around making sure that we weren't making them stay up until midnight just to cut a release. And so there was some handoff issues there that we worked through, but required a little bit of scrambling at the last minute. This was more public-facing. If you look at the public issue 71411 and look at the number of times the description of that was edited, the initial announcement and text tried to lay out which versions and which configurations were impacted, but a lot of questions kind of revealed that there was confusion about that. And so part of this was because there were 2 escalation paths with 2 different permission levels that affected 2 different version ranges. So the kubelet pod exec attach path affected all the way back to 1.0. The aggregated API server path affected back to, I think, 1.6 or 1.7. And so because there were 2 escalation paths for 2 different version ranges with 2 different permission levels, it just led to a fair amount of confusion. There were also questions about which versions were vulnerable for users that are using commercial distributions. So not consuming the open source release artifacts, but consuming something from a commercial vendor. And so some of the follow-up items for that were to be sure that we include very concrete steps for determining if a cluster is vulnerable. Not necessarily a proof of a concept exploit, but if you look at the what we ended up with in the description, what we ended up with was a lot more specific than the original text. So something like, if you are at above this version and you have an aggregated API server and this command returns aggregated API services, then you're vulnerable. And so one of our follow-up items is to make sure that the text around affected configurations is very specific, very concrete, and whenever possible provides commands to run to diagnose whether a particular cluster is affected. One of the slightly odd things about this particular incident was that the bug had already been reported publicly, but without reference to its security implications. Additionally, the Rancher developers, once they figured out what the issue was, had fixed the issue in a patch, again, without reference to the security implications. And so we found ourselves in kind of the odd position of pre-disclosing the security issue to distributors and giving them a patch that was essentially already available publicly elsewhere. And so we couldn't, in good conscience, say that the patch was embargoed, but the security implications of the patch were embargoed. And so we got feedback that that was difficult to understand, and some very security conscious distributors probably went overboard in how cautious they were, to the point of not even giving their teams the patch that we had sent them because they didn't want to break embargo. And so we definitely heard the feedback that the communication with distributors needs to be very explicit, very clear. You may do this, you may not do this. You may produce builds, you may not produce builds. You may install those builds in hosted environments. You may ship builds to end users. Whatever is or is not allowed under the embargo needs to be very explicit. And so we will be updating the announced templates that we use to send out pre-disclosures to be explicit about what may and may not be done prior to the embargo lifting date. Another point of feedback was that coordination between distributors was difficult. Again, people were being very conscientious, which is greatly appreciated. But in cases where there were two distributors that were both on the pre-disclosure list and also have shared customers or installations, it wasn't clear how they were supposed to coordinate on the issue while under embargo. And so one of our action items is to make sure that there is a communication channel for distributors on the pre-disclosure list to coordinate prior to embargo lifting. This last bit is probably not interesting to anyone except the product security team. But again, things atrophy, and since the last time we had a security release, some of the channels that we announced things on had changed. So the Kubernetes users group got archived and the Discuss forum got created, and we didn't have posting permission to the right places in the forum or the announcement Slack channel. And so it's kind of inside baseball, but making sure that the people who are supposed to send out announcements have permission to do so. And if we jump down to the follow-up items, some of the things around process that we're wanting to take into consideration, having multiple patch managers per release, which is something the release team, SIG release, had already planned to do for 1.14, which is great. Having backups for that is great. Spreading those across time zones would be even better if possible. And so that's being added to the things to consider when picking patch release managers. Some follow-up items to simplify and clarify how the distributors announced list is maintained. There were some questions around which companies were on the distributors announced list. And so we have an action item to figure out how to publish membership of that list, just for transparency and to demonstrate that the requirements, the public requirements for being on that list, are being followed, and make it easier to coordinate and inform people who want to know who has access to that information. And then the things that I mentioned about updating our templates to make sure that we are as specific and concrete as possible with the information we give people. So that covers both the technical and the process feedback and action items from this incident. I will pause again and just ask if there are any other questions or pieces of feedback that people would like to consider.
So I have a question.
Sure.
Which is the length of, sometimes things take a long time to realize they're a security incident. And I think that with Kubernetes, like anytime you have a platform that's open source, that's then other people use, and then they get bugs, right? There's always going to be this challenge. And so I'm just curious whether there has been any thought to, or maybe there already are structures for like Kubernetes, people who are deeply involved in Kubernetes, somehow participating, being on the lookout for bugs that are reported in the software that uses Kubernetes, that happens to be like, be visible in some way, or do you know what I mean? Like some faster channel for, not like, I think if it was like not specifically for security, but for bugs in general, that with some security people looking on, there might be kind of a faster channel, if that makes sense.
Yeah, that's an interesting question. I don't. So if you look at our dependencies, we actually do monitor our dependencies for security vulnerabilities. But kind of going the other direction and saying, oh, this thing is built on top of Kubernetes and encountered a bug that maybe looks suspicious, I don't think there's any monitoring of that. The volume that would involve probably isn't tenable given the current number of people who are watching these issues.
Of course.
Yeah.
I'm just thinking about it like, in the parallel in a if Kubernetes and all of its all of the platforms that use it were part of one company, this type of thing would be flagged by support, right? Support would go, oh, somebody reported a bug. Well, actually, maybe this is something that is, actually belongs in a different component, right? And then those channels end up discovering security things quicker, right? Than what happens in open source. And so if there are, like, I'm just wondering whether there are groups of people, right, who are more in the end user community aspect, right, who are thinking about just the massive bugs that Kubernetes, like any platform has, right, and the users of that, and if there are any pre-existing structures for corralling that feedback that we could insert some security experts into, or some training into, or something, so that the people who are maybe not specifically looking out for security might learn to spot this kind of thing.
Yeah, I think the two dimensions of that, one is kind of distributing across companies or products. One of the goals actually of the distributors list is for it to become a two-way street, where it's not just here's a way for distributors to find out about issues, but it is increasing awareness of the security process and trying to get in place identified people for all of these different distributors and products that are thinking in terms of security issues. And so as we add more companies and products to that list, it helps us kind of get points of contact for those products and companies, and build relationships where if they see something that's odd, they have a working relationship with us already, and know how to go about getting that information to us. The other dimension, I said there were two dimensions, and now I've forgotten the second one.
I think the distributor list is the direct
relationship
with a company, right? And then I think the other dimension.
I remember what it was.
Outside world.
One of the other dimension is across like the Kubernetes project. not just in sig-auth or the product security team. We're looking at the process that changes to Kubernetes goes through. So the KEP process, Kubernetes Enhancement Proposal, looking for specific questions and evaluation of security impact of changes. So trying to make sure that this is something that everybody in the project is considering as they're making changes or working on issues. And so that dimension is trying to improve it, security being something that everyone in the project is aware of and cares about.
Great.
Yeah. All right. Well, if no one else wants to mention anything now, these issues are open and available for following or commenting on. And as always, if you have other ideas, please feel free to open issues or contact the product security team. This document will be published and made available in kind of a final form on the website. I will send a link to that out to the same 3 SIG lists and to Kubernetes Dev. I want to thank everyone for joining, and happy holidays.
Thank you.
Thank you very much.
Thanks, Jordan.
Thank you.